Hello everyone, this is Dr. M.G. Praveena working as Associate Professor in the Department of ECE at R.M.K. CET. In this video lecture, I am going to analyze the current series feedback amplifier, which is otherwise known as series feedback amplifier. The highlights of this video lecture are: we are going to discuss the input resistance of the feedback amplifier followed by its output resistance. We are going to discuss what is the block diagram of the series feedback amplifier in this slide. Okay, look at the slide here. We divide the feedback amplifiers into two sections. One is called as the amplifier section, the other one is called as the feedback section. So we have two sections. One is called as the amplifier section, the other one is called as the feedback section. In the amplifier section, we use four types of. Here we use current series feedback amplifier. So for current series feedback amplifier, we use a transconductance amplifier. The feedback network have a gain of beta, which consists of R, L, C elements. Here the input signal is nothing but your current signal. Okay, so topology. Why we say it is a voltage mixing and current sampling topology? Here we take the sample, okay, the output sample is. So by taking an output sample as a current, the feedback voltage is nothing but Vf is equal to beta I naught. So we mix your feedback signal with your voltage signal. You cannot mix your current signal with the voltage signal. While you go for a mixing concept, you have to mix the signals with the same magnitude and your content. Right, so here what I am going to do is I am mixing the voltage signal, okay, that is your Vs with what, your feedback signal. So it is said to be a voltage mixing concept. So as a whole, this series feedback amplifier is otherwise called as voltage mixing current sampling topology. Next thing is we are going to see what is the type of the connection that this circuit block diagram has. Okay, this block diagram has series connection at the input and series connection at the output. Hence, this circuit, okay, this amplifier is feedback. Okay, before getting into the analysis, you should understand the basic three parameters that is required for derivation. The first thing is you should know what is the gain of the amplifier with feedback, that is nothing but GM. What is GM? GM is nothing but the gain of the amplifier. So what is the nature of the amplifier here? We use transconductance amplifier. So it is said to be a gain of the transconductance amplifier without the feedback. So conductance, so current by voltage. So I write current by voltage. So I by V. Right? So normally when you go for any analysis, any parameters, you write output parameter divided by input parameter. The nature of the output parameter is I naught and the nature of the input parameter is what here? Vi. Right? So Gm is equal to I naught by Vi. The next one is beta. You are going to determine what is the value of beta. Beta is to be a feedback factor. So beta is equal to Vf by I naught. Vf is nothing but the feedback voltage divided by current. What is the current here? Output current. That is nothing but the sampling current parameters your output current. Then the next one is GMF. What is GMF? GMF is nothing but the gain with the feedback. So it is nothing but I naught by Vs. So you should understand these three parameters. What is GM, what is beta and what is GMF. So GM is nothing but the amplifier gain without feedback. Beta is nothing but the feedback factor. And the next one is GMF. Diagram by replacing your amplifier internal blocks. Okay, so the amplifier internal block has been replaced since it's a transconductance amplifier. when you how to derive RIF, so it's our input resistance. So RIF is equal to any resistance can be calculated. RIF, I can write on this as VS by IX. So what I can write on voltage divided by input current. So input voltage is Vs, input current is values of Vs and II. We'll focus on the input circuit. Apply KVL at the input circuit. Now write the equation for naught minus beta IGM. So now arrange your I terms on one side. So I have grouped I terms on one side. Then from this I is common, so you can take down I. So from this you rewrite V by I. So V by I is. Now look at this two expression. In this expression, you are going to find out the relationship between R0F and R0. R0F, it is the output resistance with feedback. What is R0? It is the output resistance without feedback. While looking at this expression, it is so clear that R0F is very much greater than R0. How many times it is greater than 1 plus beta GM? So the input resistance without feedback. So from this analysis, okay, it is so clear that when we adapt the current series feedback, the input resistance as well as the output resistance will be higher. Okay, then the applications of feedback amplifier, you should know where we use this feedback concepts. We can use this in regulated power supplies. Okay, for when we use RPS, they use this feedback concept. And the second one is we can use this amplifiers when a large bandwidth is required. When we use for large bandwidth networks, okay, for communication purposes, we can use this amplifiers, and we can use in electronic amplifiers. Okay, hope you understood the concept of your current series feedback amplifier, followed by the input resistance analysis and output resistance analysis, and finally ended with the applications of feedback